In this video, we'll be discussing a few short questions on networking, mainly numericals. So the first question we have been asked is, the bandwidth of a signal is 5 kilohertz. Okay, the bandwidth that is given to us is 5 kilohertz. So the given bandwidth is 5 kilohertz and the lowest frequency is 52 kilohertz. Okay, so I'm denoting the lowest frequency as b suffix small l. So the lowest frequency that is given to us is 52 kilohertz and we are being asked to find the highest frequency. So we are being asked to find the highest frequency. We know that bandwidth is the difference between the highest frequency, okay, this should be in lowercase, and the lowest frequency. Bandwidth is the difference between the highest frequency and the lowest frequency. The bandwidth is given to us, it is 5 kilohertz. The highest frequency is what we are being asked to find, and the lowest frequency is 52 kilohertz. So the highest frequency, if you take this minus 52 to this side, you get highest frequency as 5 plus 52, which comes out to be 57 kilohertz. So this is my answer. 57 kilohertz is the highest frequency for this problem. Okay, now moving on to the next question. Let's take up another question and see how we can solve it. The next question that is being asked is, if 10 devices, there are 10 devices connected using mesh topology. So what happens in mesh topology is, every device is connected to every other device in the network using a dedicated link. We are given 10 devices connected using mesh topology and we are being asked to find the number of ports. So as I mentioned that in a mesh topology, let's say you have a network of 3 devices. So this is device 1, this is device 2, and this is device 3. So you have 3 devices, and these 3 devices are connected using mesh topology. What will happen? Every device will be connected to every other device using a dedicated link. See, D1 is connected to D2 using a link. Let's call this L1. D1 is connected to D3 using another link, L2. D2 is connected to D3 using another link, L3. Right? Am I missing any other link? No. Every device is connected to every other device. That means you will have a dedicated link between every pair of devices. So if you have to have a dedicated link between every pair of devices, how many ports should each device have in a network? So if I have, see, let's take up this example. In this example, how many devices do we have? 3 devices. Now each device has to be connected to every other device. That means D1 should have 2 ports. Similarly, D2 should have 2 ports. Why? Because D2 has to connect to D1 as well as D3. So these 2 ports, one will be to connect to D1 and the other will be to connect to D3. So it should have 2 ports. Same for D3. That means given n devices in a mesh topology, the number of ports that we get is n minus 1. The number of ports that we get is n minus 1. Extending this question a bit, had we been asked to find the number of links, what would we have done? See, in mesh topology, if you are asked to find the total number of links, the formula is given by n into n minus 1 divided by 2. These many links are present in a mesh topology. You can apply this formula for this. How many devices? N denotes the number of devices in the network. How many devices do we have here? 3. So if you substitute 3 in this formula, you get 3 into 2 divided by 2, which comes out to be 3 links. How many links do we have here? L1, L2, L3. 3 links. So this is how you find the number of links in a mesh topology and the number of ports in a topology of devices connected using mesh. So this was question number 2. Let's take up another question. Now in question number 3, we are being asked, or rather we are being given 5 routers. See, the question that is being asked is, if there are 5 routers and 6 networks. There are 5 routers and 6 networks. There are 5 routers and 6 networks in an intranet. So an intranet is a network of devices pertaining to a specific organization. So in an intranet, using link state routing, so if there are 5 routers and 6 networks in an intranet using link state routing, what is the total number of routing tables? Find total number of routing tables. Find total number of routing tables. So see, you take up any network of devices using any algorithm. If there are routers, every router will maintain a routing table. Now how many routers do we have here? We have 5 routers. Now every router will maintain a routing table of its own in order to be able to route packets to all networks it is connected to. As a result, here we have 5 routers and we are being asked to find the total number of routing tables. So if you have 5 routers and if each router maintains a routing table, how many routing tables will you get in total? You will get 5 routing tables. As simple as that. Okay, so this has nothing to do with the protocol or the algorithm that is used in order to route packets. Here we are being given 5 routers and we are being asked to find the total number of routing tables. We know that every router will maintain a dedicated routing table of its own. Therefore, we get total number of routing tables as 5. Okay, moving on. Let's take up another question. So these short questions are asked in your MCQ portions. Next question. The next question is, we have been given, this is question number 4. Okay. So in question number 4, we are being given a subnet mask. We are being given a subnet mask which is of the form 255.255.192. Okay. .192. So this is my subnet mask. This is my sorry about that. So this is my subnet mask and we are being asked to find the network portion. Okay, so this is the subnet mask that is given to us and we are being asked to find the network portion of this subnet mask. What is the network portion of this subnet mask? See, what does a subnet mask represent? A subnet mask represents, subnet mask represents the total number of ones and zeros that will help us to identify any IP address as belonging to a particular network. I'll give you an example. Let's say you have 2 networks. Say you have network A and you have network B. You have network A and network B and you have, so that there has been subnetting. So let's say this is my entire network, let's call it N1. It has been subnetted into 2, subnetting has been applied and you get 2 subnetworks, NA and NB. Now whenever subnetting is performed, an internal router is provided. An internal router is provided by the internet service provider and there is an external router as well that is connected to this entire network, which is N1. Now say this is my interface I1 and this is my interface I2. Now packets that are incoming packets to this network have to be routed to either this network or this network. That means they have to be routed to devices present in either of these two networks, right? Incoming packets to this entire network N1 have to be routed to either devices present in network NA or devices present in network NB. Rather not network NA, we can call it subnetwork NA. So how will this routing takes place? When will this internal router of mine, when will it choose I1 and when will it choose I2? Rather, the more pressing question is, how will it choose this interface I1 and how will it choose this interface I2? The easiest answer is use subnet mask. What happens is subnet mask, if you take the IP address of any host and if you perform an AND operation with the subnet mask, what you get is the network ID or the network address in which the host is present. I'll repeat again. Let's say you take the IP address of this particular host and you perform an AND operation, bitwise AND operation with the subnet mask. What you get is the network address in which the host is present. So using the subnet mask, the internal router will be able to identify which interface the incoming packets should be forwarded to. Now, subnet mask, I'm writing it in short as SM. Subnet mask represents the network ID as well as the host ID. Now, how does the subnet mask come about? The network ID is substituted by ones and the host ID is substituted by zeros. And mind you, the host ID also includes the subnet ID. Whenever you are performing the subnetting on a network, you will have to choose bits from the host ID, never from the network ID. Whenever you have to perform subnetting, bits have to be chosen from the host ID part, not from the network ID part. So this subnet mask, how many ones does it have? See, here 255 represents 8 ones. So you have 8 ones here. You have another 8 ones here, that's 16. Another 8 ones, that's 24. And how many do you have here? Here you will have 2 ones. See, 192, which is my decimal value, can be represented in binary as 128 plus 64, which is 192, and the rest are all zeros. So it's 5, 6, 7, 8. So this is the binary equivalent of 192. This is the binary equivalent of 192. So how many ones are you getting? You're getting 8, 16, 24 plus 2, 26. So you're getting a total of 26 ones. That means the network ID extends to a portion of 26 bits. The network ID extends to a portion of 26 bits because the total number of ones in my subnet mask is 8 plus 8 plus 8 plus 2 in this 192. See, this 192 I've written it over here. This 192 has been written over here and the binary equivalent is this. So if you count the total number of ones in this entire subnet mask, what you get is the network ID portion. So the network ID portion comes to be 8 plus 8 plus 8 plus 2, which is 26 bits, and the remaining portion is my host ID. And from the host ID, I'll be selecting bits in order to perform the subnetting operation. Okay, fine. Now let's take up another question. The next question, let's see what we'll get. We first erase the board. Moving on to the next question, let's see. So another question that has been asked is, a subnet mask, another question on subnetting. A subnet mask in class A network, a subnet mask in class A. Okay, you are performing subnetting on classful addressing. So a subnet mask in class A, where did it go? Yeah, in class A network has 14 ones. Has 14 ones. Okay, and we are being asked to find the number of subnets it defines. We are being asked to find number of subnets. We are being asked to find the number of subnets. Whenever they say a particular class, whenever they mention the class of the IP address, that means we are following classful addressing. So the network ID and the host ID will have fixed portions, and we are using class A addresses. So in class A, for class A, we know that the network ID is of 8 bits and the host ID is of 24 bits. Right? Network ID is of 8 bits and host ID is of 24 bits. Now subnet mask has 14 ones. So if the subnet mask has 14 ones, that means we have, see, if there's a subnet mask which consists of 14 ones. So there are 8 ones which represents 255, and then there are 6 ones. So 6 ones will be 1, 2, 3, 1, 2, 3, 00, and the rest are all 0. So this is my subnet mask. If I convert this binary pattern into decimal, what will I get? 128, 192, 194, 224, 240, 248 and 252. So this subnet mask is 255.252.0.0. So I'm simply writing the decimal equivalent. See, this binary pattern has a decimal equivalent of 252. So this is my subnet mask, and we are being asked to find the total number of subnets. Fine. Now in the subnet mask, what we can find is, see, the subnet mask that is given to us. Are we given any more information in the question? Let me have a look. No, we are being only asked to find the number of subnets. Okay. So the subnet mask will represent the network ID portion. Since the subnet mask represents the network ID portion, what we get is, we get 14 ones. Now from the host ID, we know that class A has a host ID of 24 bits. So in my subnet mask, what I am doing is, I am performing subnetting. That's fine. This portion of my subnet mask represents the network ID, right? And this entire portion of 24 bits, this represents my host ID. In the earlier question, what did I mention? We'll perform subnetting using bits only from the host ID. That means from these 24 bits of host ID, how many bits have been taken? 1, 2, 3, 4, 5, 6. 6 bits. See, these 6 bits have been taken from the host ID, and what have they been used for? They have been used for subnetting. So if you take 6 bits from the host ID, then how many subnets do you get? You get 2 to the power of 6, which is 64 subnets. You get a total of 64 subnets. How did I find this? See, it's very simple. Class A has a network ID of 8 bits and a host ID of 24 bits. The subnet mask that is given to me has 14 ones. Now since it has 14 ones, the network ID is of 8 bits, so up to this portion it's fine. The remaining 6 ones are coming from the host ID part. And if I'm selecting bits from the host ID, what am I selecting them for? I'm selecting them for performing subnetting. So if I select 6 bits from the host ID part, what will I get? How many subnets will I get? I'll get 2 to the power of 6, that is 64 subnets. It's simple, right? If you have 2 bits, see, if you take 2 bits, how many combinations do you get? 0, 0, 0, 1, 1, 0, 1, 1. So you get 2 to the power of 2 combinations, right? Similarly, if you have 6 bits, you get 2 to the power of 6, that is 64 combinations, that means 64 subnets. So you take the host ID part, from the host ID you see how many ones are being used. See, the host ID is of 24 bits and number of ones that are being used from the host ID are 6. That means 18 bits will be left for the host ID portion and 6 bits will be taken for the subnet ID portion. So since 6 bits have been taken for subnet ID, we get 2 to the power of 6, that is 64 subnets. So I hope these questions will help you in clearing your concepts. I'll see you in the next video. Thank you.